Hello, everybody. Welcome. This is Brian for Breaking Down Security. And this week is another special podcast. I know some of you have enjoyed the audio that we've gotten from various conventions that we've been to, whether it be DerbyCon or the other ones. I forget which ones they are, but this one is from a conference called SourceCon, and we interviewed two different groups of people. Actually, we had the first interview will have two people in it, Lee and Paul from Pre-OS Security. And the second one is Joe Basirico from Security Innovations, talking about bug bounty programs and how to get the most out of your bug bounty program. He also spoke at Source. Very interesting conference, Source Seattle. I've been to the one last year and one this year, very much like a B-Sides. And the amount of discussion you get and the kinds of talks that you get are very, very nice. So we had everything from threat modeling with Robert Hurlbut, who we've had on the show, to really highly technical discussions about chip diagnostics with some of the folks in the afternoon, and we've had people like Adam Shostak on and Gunther Ullum from Microsoft. Adam now works on his own, and so yeah. And there's workshops about not even about security stuff. It's like, the threat modeling one was Robert Hurlbut. The other one was the public speaking. So if you're not very good at speaking, it bothers you. Rob Chain, who actually organizes SourceCon, does the workshop on how to be a better speaker. So, I mean, that's, all of the talks and the workshops that you get at Source are real, actionable, topics that you can take back and start working on immediately in your organization, which I think is most excellent. So, like I said, the first talks that you'll hear is Lee and Paul talking about firmware security and UEFI security in your computers. And the second one is Joe talking about how to get the most out of your bug bounty program, how to have a collaborative environment. So before I go, we have an intro to reverse engineering course. It's being taught by a good friend of ours, Tyler Hudak. He analyzes malware, but he's asked us very nicely to set up some reverse engineering courses. So you can go to our Patreon, and there's instructions on how to do the sign up there. I'll also put a link in the show notes to the syllabus. For instance, so to give you an idea of what you're going to learn in the class, if you sign up, session 1 is about Introduction to x86 assembly, Introduction to x64 debugging. So you'll learn things like breakpoints, imports and APIs, and patching code. And there'll also be an introduction to IDA Pro. So you'll get to understand shellcode, and there's a bunch of other stuff in the other 3 sessions that you're going to learn. Some of the prerequisites are, there's a book that he's asked you to look at if you want to understand more of the basics of assembler at beginners.re. I also suggested the PC assembly book at pacman128.github.io. And some of the things you'll need to set up for the class you can get at modern.ie, and the freer demo version of IDA Pro and x64 debug. All that information is in the course syllabus, and you can find that in the show notes. So that was it. I just wanted to put out a quick hey for the class. It starts on October 30th, by the way, so you still have some time to sign up, and it goes for 4 Mondays. So you'll still have plenty of time to sign up if you're hearing this just now and didn't know what was going on. So that was it. Join us on our Slack. We have an active Slack. You can hear us talking about all kinds of subjects on there. Well, not hear us, but you can, there's a lot of topics going on the Slack. We've got a lot of different channels like security architecture and vendor management channel. We have a SIM channel, which is quite active. We have a malware and reverse engineering one. We have vulnerability and breaches channel, which is actually very active because the week of the 17th was the crack Wi-Fi access point vulnerability. So everybody was talking about that. And we have a lot of stuff going on. So join us at breaksec.signup.team. And you can join us. We have 700 and almost 800 people in the hallway con. So please join us. So that was it. I'm going to leave you in the capable hands of Paul and Lee and myself at SourceCon. Have a great week. We will be back next week with an interview, hopefully. So that was it. Have a great week, and we'll talk to you again soon. So hello, this is Brian from Source Seattle 2017. Doing some audio from this conference, which was actually the first day has gone really great. Had a workshop with Robert Hurlbut, who we've had on the show before, about threat modeling, which was very eye-opening. Some things I've learned that I didn't expect. So I couldn't get Robert because he's got some NDA issues with his new company. We'll try to fix that later down the road. But today I have some people who are going to be speaking tomorrow, and also at something called Seagull, which is in Seattle. So we have Paul and Lee. Welcome to our show.
Thank you.
Thank you.
All right. So you guys run a company that you've just started. You're all startup-y and whatever, called Pre-OS, or what you call it, Pre-OS?
So I like Pre-OS better myself.
Uh-huh.
But we've had all sorts of people responding for that. So we're focusing on firmware level security. And when we talk about firmware, we're talking about mostly assembly code or binary blobs. We're not talking about Internet of Things in our case. We're talking about what's called platform firmware. So the embedded Linux that you get on your router is not in the scope of what we're talking about. But firmware level security is a critical area. It's new. The saying goes, firmware is the new software.
Okay, so there have been like news recently about Intel's management processor that was activated and was running over specific ports on the NIC, and people found out that there was a way to disable this. Is this what kind of stuff you're talking about? Firming, securing that and making sure that people don't get taken by that anymore?
Actually, you kind of caught me there. So Intel's management processor is actually a great example. That's actually baked into the Intel chip itself. But a lot of that kind of technology, or previous versions of that technology, like IPMI and Redfish, other ones were on a secondary onboard processor, and effectively that was another embedded Linux. So that would be a whole firmware install. In this case, since we're talking about something that's actually on the processor, now the only way to fix it is with a microcode update, or some other lower level type of fix. That one was a very good example of a recent huge problem. So Intel shipped these chips; they're out in the field, and now they have this problem that can only be addressed at the firmware level.
Okay. And microcode, for those of us who don't understand, is what we use to update processors and BIOS?
Yeah. Microcode basically is the firmware that updates the instruction sets. So if Intel has a problem with its instructions, microcode can patch that.
Okay. So back in the day before UEFI, everyone would boot to DOS, regardless of the OS they had, flash whatever Phoenix BIOS or whatever it was, with a floppy drive or whatever, and go on. How has that changed with UEFI and with the new forms of firmware?
So I think one way of thinking about it is that UEFI itself is almost an entire DOS by itself. It has loadable modules. You can run Python code in it, JavaScript now. So it's a fairly complex system in and of itself. UEFI though is just one of the many firmwares on your motherboard. You've got PCI blobs. You've got ACPI, you've got the management and AMT that you mentioned earlier, USB, basically anything and everything you can plug into your computer, and most of the major subsystems on your computer have their own firmware. Every hard drive has its own firmware on the actual hard drive, and then there's firmware corresponding on the controller side that talks to that hard drive. So all of these can and have been hacked, basically. There's at least a few examples in the wild for just about every firmware you can imagine. Even monitors nowadays have firmware embedded in them. So that has been hacked at last year's Black Hat, 2016.
Okay. So I'm going to get Lee in here eventually. So Lee, you're both local Seattle, right?
Yes.
Okay. So, Lee, you were talking to me last night at CSEC East about the coprocessor actually runs Minix.
Well, so the Intel management engine is what we were talking about earlier. It's recently been reported by security researchers that it contains strings that are also inside the Minix kernel. So therefore, they're assuming that it's based on the Minix operating system. So that's kind of humorous. Recently, the security researchers have discovered how to disable the management engine. So I think Coreboot has that ability now, and that's going to make life a little bit more interesting for security. There's the people that discovered how to disable it. Now they're giving a talk at Black Hat on how to run your own code there. So it's going to become more interesting because you might find more malware there now, not just Intel's tools that you didn't know what they're doing. Now you might find malicious code.
You mentioned Coreboot. Is that a flavor of firmware operating system?
So Coreboot is an example of a system firmware technology and bootloader. In the old days, it was BIOS. UEFI is now kind of the new one for Windows machines. Chromebooks use Coreboot. Coreboot is used in a variety of embedded Linux systems. Another technology related to Coreboot is U-Boot, DOS U-Boot, another bootloader. So Coreboot is used on Chromeboxes and a variety of Linux machines. It gets rather interesting because Coreboot and U-Boot both load payloads, and they both now have the ability to load UEFI as a payload. So Coreboot can load UEFI. It's kind of interesting.
So it'd be like bootstrapping a Windows kernel through Grub.
Also UEFI has kind of a two-part initialization phase. The first part's called the platform initialization, PI, and then the latter part's the traditional UEFI component. And there's a technical mixture of Coreboot that uses Coreboot as the payload for the initialization code for UEFI. So there's yet another way to do it. You can mix up Coreboot and U-Boot and UEFI, but in general, UEFI you'll see on Windows boxes and on servers, and you'll see Chrome on Android machines and on Chrome boxes.
Okay, so tomorrow your talk is about what?
So the talk we're giving is on how blue teams should be looking at firmware and enterprises, how to defend your system. So mostly it's looking at Intel UEFI systems, how you would examine the firmware for malware. So techniques to dump the ROM into a file, so you could do offline processing on that file. Dumping that file every night, diffing the file, looking for changes, and those changes may be an evil mate attack. It may be a firmware update with vendor changes. Right, so you have to understand what's there. The biggest problem I think right now with firmware is that most security people don't look at firmware. They only look at operating system binaries and app binaries. And so when they talk golden images and all that, that's great for apps and operating systems, but they're still using an unknown blob for their firmware. They're not checking it for malware. They don't know when things change. They don't know what's in it. It's rather scary.
So I don't know of any blue teams. At least when I was doing blue teaming, I never updated my firmware. So what's the threat model for somebody who needs to update their firmware and worry about malware? Are we talking like nation state kind of stuff?
Well, firmware level attacks are more difficult than software level attacks because software is easier to install. And firmware is harder to install, so it's harder to create firmware level malware for that reason mostly. If the malware is done right, it's fairly machine independent because UEFI works on a variety of platforms. So you could make a piece of UEFI malware that would work on a variety of architectures. But firmware is just software. It's just stored on flash instead of on the hard disk. And so all the kind of tricky exploits you can do with software malware, you can do with firmware malware. It's just harder to install it. Firmware has been evolving over the time, and now there's better, easier tools to use this. And so perhaps it's, like in the past with security, once tools got good enough, script kiddies started doing things. And perhaps it's getting to the point where the firmware tools are getting good enough that script kiddies can become evil maids now.
Right.
For some models of machines.
So how would somebody introduce malware onto a computer? Would it be a rogue thing, like, click here to download this payload and install it? Or are we talking like where you can plug a thumb drive or like a Thunderbolt port where you have direct memory access to be able to flash? I mean, what are we talking about?
So there's multiple ways to attack firmware. Obviously, you can USB firmware is an interesting way. Rebooting a system with a USB device with a UEFI shell on it, but it's actually gotten fairly easy now that Windows updates firmware update blobs from vendors, not all vendors, but many vendors. This means that there is a user mode application that updates the firmware, and so if you have root, if you've obtained root access on that operating system, you could use that mechanism to update the firmware. If you had a firmware blob that you wanted to put in malware or in firmware, you could use the update tools possibly. So looks like Paul's got something else to say.
Yeah, earlier you asked about what the threat model was, and I wanted to say a little bit more about that.
Okay.
Yes, to date, most of the exploits that are known are nation state level. One of them was Hacking Team, which is a group that is known to operate at the nation state level mostly,
right,
even though they're a private company.
Okay.
But what I wanted to say is that I think a better way of thinking about the threat model is rather than the type of attacker, because we've seen historically that nation states, well, in recent history, nation states have been a little bit ahead of the curve. They're attacking different targets. They're able to spend a lot more on resources and so forth. And non-nation state actors are focused more on financial returns, and why not just go for the easiest thing? Then you get more for your money if you spend less time focusing on the attack and more time mining Bitcoin or what have you. But I'd like to really highlight that a firmware level attack in this case is more going to be about the goals of the attacker necessarily than the attacker themselves. So if your goal is to be persistent or to be invisible, and both of those things are things that are much harder to do with sort of your standard virus or malware, where the antivirus is constantly evolving and so forth. It's much easier to be both persistent and invisible at the firmware level. Even if what you're doing effectively is injecting a virus, you can just keep doing that and or iterate out of that problem there.
Right, because this bypasses AV. This would bypass any endpoint solution because it's below the OS.
Currently.
It's constantly running in persistence.
Yes, yeah.
Right.
So obviously, as Lee mentioned, part of the threat model there is there is a focus on physical access, and so I think if your threat model includes that you have mobile machines that you're losing contact with, if you're an individual consumer and you're traveling and you hand your laptop over to the TSA, now maybe that TSA actor is technically a state actor, but maybe he's just some guy who wants to who also is getting a little money on the side to hack for some private company, corporate espionage. That would be a use case where you literally have to hand over your machine, and now a firmware level attack is easier. But as Lee said, you don't need physical access to do that anymore. You can attack with a normal malware and then inject something in the firmware level, and that's the end of that there. And you've got a persistent, invisible threat there.
Right on.
And Lee's handing me a note here. He said to emphasize that these kinds of attacks nowadays can work even when machines are off, and that gets back to your thing with Intel management technology. The management technologies are designed to handle machines that are powered off, so that you can power it up remotely. For example, using Wake on LAN. And some of these embedded systems, such as IPMI, are designed to just stay on even when the rest of the machine is physically powered off. So you've got a whole other network interface that's always live. Doesn't even need to be woken on LAN. So that's and of course, a lot of the portable machines have batteries, so they're able to be in a mode where they have some low power component that's actually on, usually running one of these low level firmwares that is potential for compromise.
Okay. Cool. All right. Well, I don't want to waste all, get all the secrets out, because I'd like to go and have a full show about this at some point in the near future, because you guys are still developing. This is in an alpha stage, whatever it is you're working on. You have an application, right? Or something?
Yeah. So what we're working on is something very similar to antivirus, but for the firmware level.
Okay.
So we expect to have a release fairly soon of an open source version that will be sort of our initial version of the software available to anybody who wants to use it, and then over time we'll release a management console, and you'll be able to manage a fleet of machines that way, and or integration with your whatever your enterprise single pane system you're using.
Okay.
So we'll be able to feed our data directly into that and tell you a lot more than you ever knew about your firmware on your machines.
Right.
So, yeah.
Okay. So, but before we go, I want to ask Lee, did you see any interesting talks today that you thought were good? I have to ask because you were an attendee, so I'm going to ask other attendees. But I've got a captive audience.
Yes, of course. The threat modeling talk was excellent.
With Robert?
That was a great talk.
I found it interesting because he's talking about threats are the goals of the attacker, and those are the things that they're trying to accomplish for which I found like a different point of view. I was like, oh yeah, they're not threats; those are attacker goals, and that's almost a positive way. They're goal oriented people, so now they're like the threats that are out there are actually the goals of what they're trying to accomplish. So I really would like to have Robert on, but his new job says he can't do that. So we're going to have to figure out something. We have him on the show and we just don't name names or something. I don't know. But yeah. So are you guys looking forward to any talks other than yours tomorrow?
Thanks.
You're looking at the
Thanks for putting me on the spot, of course.
That's okay.
I was looking forward to Rob's talk on the new technology and old vulnerabilities.
Yeah.
And
now, which
and
one?
obviously Adam's keynote.
Right.
Right. Adam's a friend of ours. So,
yeah. So which workshop did you go? I went to the threat modeling workshop. Did you go to Rob's public speaking one?
I was at the threat workshop with you. So.
Okay. As he says, waving me off. All right. Well, we definitely want to have Paul. We definitely want to have Paul and Lee on to discuss this more in depth, because I would really be interested in this. And we also want to do one on supply chain security in the near future, because there's so many instances of not knowing where your information is coming from. People have WordPress plugins that they don't monitor, and they just, we'll just install this one, and it opens like cross-site scripting and all kinds of issues. So there are a bunch of things out there, like CC Cleaner's a prime example of supply chain security. You install it thinking it's all good, and you get owned from it. So do we want to mention the ebook? Is it out yet?
So the ebook isn't out. It'll be out probably next week. Next week. And at the moment, you can get a free copy of the ebook if you go to our website and sign up for. Actually, you don't have to sign up for our newsletter. You can just say, "I want a free copy of the ebook." So,
okay.
But I would recommend you also sign up for we're going to do a quarterly newsletter with firmware security updates. It's sort of an obscure corner of the security world.
Yeah.
These won't be CVEs, of course. You should be on those as well, but we'll have a little bit more of our own flavor and information that we will provide via our newsletter.
Does MITRE not supply CVEs to firmware
yes.
updates?
Yeah, there are CVEs that come out, but I'm gonna boast for Lee that he's way more on top of this in general than almost anybody else in the entire ecosystem. And his personal blog it tends to have a lot more updates. We'll
right.
condense those into a quarterly newsletter for easier consumption.
Very nice.
So this is Lee. Brief answer on the CVE question. SCAP really doesn't have an oval definition for firmware. SCAP is really only suited for operating system application level stuff. So generally, if you find CVEs with firmware, it's because you did a full text search and found the word UEFI in there, but it wasn't added to any proper oval metadata. It would be really great if SCAP and MITRE did oval definitions for firmware. Maybe the UEFI forum could work with DMTF and get a working group to get all that metadata together, and then you could finally use your SIM to track firmware data. It's kind of crazy. There's a disconnect in the area. We have tools that generate results, but there's no oval definitions to get those results into your SIM.
Okay.
Kind of crazy.
All right. So yeah, by the time this goes to print and you're hearing it in your earballs, that ebook will be available. Where do they get that at?
So we'll actually mail it out. Just email it out to you.
Okay.
So you have to give us at least your email address.
Okay. Totes not spam at yahoo.com.
Correct.
Okay. Preossec.com. Okay.
And we will be putting it up for sale on Amazon and Google Play and so forth. But primarily, we'd like to get the word out more so than anything else. So
sure,
yeah.
Understood. Okay, well, thank you, Paul and Lee, for coming on. We'll definitely have you on in the near future to talk more about this in depth. But yeah, I'm really excited to understand this better. So
great, thank you.
Thank you.
This is Brian back at Source 2017. I'm here with Joe Basirico. He's one of the speakers who will be speaking later today. Sadly, I won't be able to listen to the talk. I'll watch it online, though, because all of the talks from Source is going to be loaded up to Source's YouTube channel. So, Joe, thank you for coming on the show.
Hey, thanks.
So your talk you're giving today is building a collaborative and social application security program. First time I read it, I was like, what's a social application security program? But it's like building a collaborative and social application security program. So maybe you could talk a little bit about what that means.
Yeah. So first off, I will totally admit the title is terrible.
It needs a comma.
Yeah.
I think it needs a comma.
And the first version was just a social security program, and that definitely wasn't right.
Right.
So I'll probably change it to be something about bug bounties and how to get hackers and security researchers to talk with you and collaborate with you.
Mm-hmm.
So the idea is that there are security researchers out there that are finding vulnerabilities in your software and everybody else's software. And it's worth your while to listen to them and receive their vulnerabilities and treat them with respect and have kind of a process by which you communicate with them and kind of move them through the process. So, setting up things like a security email address is a really important first step that a lot of companies don't have. Another way that a lot of companies kind of make a mistake is the first contact with the security researcher is through their legal team.
All right.
And so we want to make that easy. We want to kind of make it easy for companies to roll out a program that allows them to collaborate with these security researchers. And then also understand when's the right time to roll out a bug bounty program. Rolling out a bug bounty program early can be super overwhelming. You can end up with hundreds of bug submissions in the first couple of weeks, and you have to have in place a plan to triage those and move them through the process, decide if you're going to fix them, how you're going to do those things, and your whole plan. So without kind of getting your ducks in a row before rolling out a bug bounty program, you want to make sure everything's kind of lined up.
Right. So I mean, we've had other people on the show talking about bug bounties and how to implement them. Is there a checklist or something that you guys follow, or when people go, hey, we want to start a bug bounty program, why would they know to come to you, one? And two, do you ever go, well, you're not ready yet because these reasons?
Yeah. So largely the checklist is just our experience. We've been doing this for 15 years or so, and we've worked with a lot of different companies and a lot of different maturities. And so what we'll do is kind of look at what the organization looks like from a security maturity viewpoint. So, and kind of anticipate what will happen if they do roll out a bug bounty program. So if you're really early, maybe the first thing you want to do is just go buy a tool, right? Like a web scanner or a static analysis tool or something like that. And we all know how those work, right?
Mm-hmm.
I chuckle and say they miss 80% of the vulnerabilities, and 80% of the vulnerabilities they report are false positives.
Right.
But they're a good first step, and they're going to find the low-hanging fruit, and they're going to find stuff that you definitely don't want to have to deal with in a bug bounty program. After that, getting an external security assessment with a real security company can be really good, because now you can start to get a little deeper, get some understanding of what your application looks like from a black hat sort of viewpoint. And then maybe shore that up with some education. So get your developers, get your testers some training, whether that's YouTube training or buy them the Writing Secure Code book or whatever you're going to do. You can start out really inexpensively. Or you can get really thorough instructor-led training and bring an expert in and have them tell you what to do. But give your developers and testers actually the tools to remediate some of these things. Go on an internal bug bash, find some vulnerabilities, fix those vulnerabilities, and then start to think about maybe getting your messaging right and how you want to frame your bug bounty program. Maybe roll out a private bug bounty program first. Mm-hmm. And then kind of go all in. But again, going full public bug bounty program straight away, that can be overwhelming.
Yeah, I mean, so I got an email from a guy because he had listened to our bug bounty talk we had with Mr. Monseeger, and he had said that they were looking at a bug bounty program, but they had to limit the testing, where the testing was coming from. So they reached out to a third party. Mm-hmm. Third party set them up with something, but didn't say, okay, only U.S. people only. Or they were like, well, we can make it U.S. only, but our really talented people are in China and Russia. And they're like, yeah, we don't want people from China and Russia testing our stuff. We don't care if they work for the government or not or whatever. How do you... So there's scope involved. So it's like, okay, you do just this application, you do the whole network. What kind of scope can you set on the bug bounty company that you may be hiring?
Yeah. So there's kind of two different ways to do a bug bounty program. So one is to roll it out yourself and just kind of do a private bug bounty program where you invite certain security researchers from all around the world, or work with a bug bounty kind of liaison where those security researchers essentially sign up with them, and then they kind of point their team of security researchers at your application. And scope is super important. One of the things that I really think is a great place to start is to look at Google's vulnerability research program. I think they've got a nice web page up there that describes their scope and describes how to communicate to them, describes kind of the terms of engagement. And that's huge because one of the things that I like about that is they say, this is in scope, totally send us vulnerabilities that you find over here. And this is what you can expect when you engage with us. This is kind of how much we pay out for different types of vulnerabilities. And then these things aren't in scope. And so they make it very clear. If we just acquired a company, there's a 6-month blackout, right? We understand that there might be vulnerabilities in this other company, and we're going to try to fix those, but we need 6 months to do that.
Right.
And that's totally fair. I think that, security researchers understand that, right? Like when you buy a company, just like you buy a truck on Craigslist or something, like you need a little while to drive around and see what needs to be fixed. Yeah. And then you can go and fix it, and then you can do that. So defining scope and that terms of engagement is hugely important.
Yeah. So you want a fairly clear-cut scope. You don't want something that's kind of ambiguous. I seem to remember like United Airlines or one of the airlines had a bug bounty program where somebody had found something and it wasn't exactly in scope, or maybe it was a language barrier with the guy, but they had a problem with the way he reported it, and they ended up paying up at the end. But so you were talking about an ombudsman. Is the ombudsman also going to be, or a liaison? You're going to be. Would they also be involved with helping to make sure a proper transmit of the bug involved, or does the company work directly with the researcher?
Yeah, it just depends on how those organizations work. Certain companies, like the HackerOnes and Bug Crowds of the world, they pretty much just manage your program. So they help you define those things, and then they give you a platform to for the researchers to send you in, and you can triage them. So you work directly with the security researchers in those scenarios. Right. Other ones, they're kind of the liaison. So they're kind of trying to do that first pass of filtering. One of the reasons why scope is so important is it can be really time consuming for both sides, right? It can be really frustrating for the security researcher to say, oh, every vulnerability we send you, you just say, oh, that was out of scope, or no, we're not paying out for that, or whatever. Yeah. That's really frustrating for their side, and it's really overwhelming for your side to get a bunch of vulnerabilities that you don't care about. So again, scope is huge. We've at my company, I have a bunch of security engineers, and they're free to go and do these security bug bounty programs as they see fit, and they get to keep the money. And I remember helping one of my engineers do the submission, and he submitted, I want to say 15 vulnerabilities to this company, and only 2 of them he actually got paid on. The other 13 were out of scope or already discovered, or for any number of reasons kind of rejected.
Right.
And it kind of took the wind out of his sails. Like, he was like all really excited, all gung-ho about reporting these vulnerabilities and making a difference. And then, getting that email back from their security team and going, oh, we're not doing it. Here's $50 for those 2 that we didn't find.
Could it be more like he was expecting a lot more money than what he got, and he was a little disappointed? Because, they all pay out various amounts. So, was it the fact that the company didn't have like a scoreboard or something, or saying, hey, we've already found these vulnerabilities have already been reported, anything that you find in those areas is off the table now? I mean, how would a company report that to, say, the company that's doing the bug testing?
Yeah, I think that, every security researcher is going to have their own reasons for doing these things. And certainly there are some real, no, I'm not going to tell no disclosure at all until I get paid out, and things like that. There's certainly researchers like that. But in my experience, a lot of security researchers, as naive as it sounds, they want to make the world a better place. They want to make software more secure. And when they see security vulnerabilities, especially some of them that in their mind are really easy to find and really easy to fix, remain unfixed or rejected because of scope, and they're not even kind of acknowledged for the effort that they put in, it can be disappointing. And so again, that kind of gets back to what I was talking about earlier with it's important to respect the security researcher's time and say, like, hey, I appreciate you sending all these over. Bugs 1 through 5 we already knew about. We have a fix in. We're gonna do this. This is what we're gonna do. Bugs 6 through 10 are out of scope for this bug bounty program, but we'll get you in contact with that right team. They don't have a bug bounty program, but at least we're gonna work to fix them.
Yeah.
And then the other 2, they're totally bugs. We're gonna pay you, and we're gonna get them fixed. That's a much nicer response than, we're just throwing away these 10 and we're going to go with these 2.
Communication is really the key.
Yeah.
So do the hacker companies like, Synac and all those, do they, so let's say your guy found those 15 bugs, 10 of them are bad, but 2 of them were good. Does he still get any kind of reputational credit for finding those 10? Because if he didn't find those 10, maybe he's not as good a bug hunter as they thought. Does he get any kind of reputational credit, or
Not to my knowledge. I think that with most of these bug bounty programs and platforms, your reputation is based on the vulnerabilities that you find and that are kind of positively acknowledged through the other organizations. So if you find vulnerabilities that they already know about or that are out of scope, you get no rewards. Now, that organization could otherwise recognize you on their own organizational leaderboard or thank you page or whatever. That's totally fair.
Yeah.
But I think that most of the time with those normal platforms, they don't get any no recognition.
Yeah, I've never actually done the bug bounty kind of thing. I was always wondering how they measured those, because there's all kinds of metrics. So if you hey, Bob found 100 bugs, but only 2 of them were good, or, Jim found 50 and 48 of them are good. Which one is a better bug hunter in which case?
Yeah. In it's interesting because if the vulnerability hasn't been fixed, right, you definitely want to tease away all of the false positives, right?
Right.
Like if you have a bug hunter that's just kind of carpet bombing with bad results, right? Like, oh, there's cross-site scripting over there, there's SQL injection over here, and it's not, then, clearly that guy's reputation shouldn't be as good. But if the vulnerability is legit and you just haven't fixed it, then that seems like you should get rewarded for it. And it can get expensive, of course. That's the other side of it is a lot of organizations don't have the budget to pay out huge amounts of money for vulnerabilities. And a lot of them, it's still a little immature, where a lot of organizations are rolling this out as a trial or kind of seeing how it goes.
Yeah. So what happens if you're like a really important company? You're like, yeah, we have a bug bounty program. Our max payout's going to be $250. Company like yours would be like, maybe it needs to be a little bit more. I mean, what kind of budget are we should we think of, and how do you? It would almost be like I don't know. You'd have to do some kind of threat modeling to go, okay, how bad can we get it, and where we should go. I mean,
yeah, it's tough. So, finding the right rewards and kind of balancing that is really important. I mean, this is where we get into like really detailed decisions around incentives, right? So, if you have no bug bounty program, but you're super thankful and super helpful when security researchers send you vulnerabilities, that might be a great social program, right? Like that might be a good program that gets people interested in working with you because they want to be on your leaderboard. Donald Knuth, one of the great computer scientists, write books, and if you find a bug in one of his books, he'll write you a check, and he writes you a check for $1 hexadecimal dollar, so $2.56. And so obviously it's not a lot of money, but you have a real check from Donald Knuth for $1 hexadecimal dollar that he writes out 100 and then hexadecimal dollars underneath, and it's awesome, and it's a huge bragging rights, and it's one of the coolest things you can get as a computer scientist. Yeah. So it doesn't have to be a ton of money, but it also has to be not insulting, right? So if you say, if I find amazing remote code execution in your prod server and I can take over everything, and you're like, cool, here's a t-shirt and $250. Yeah, people aren't going to be looking anymore.
Right.
Or
the wrong kind of people are going to be looking.
Yeah, and they're going to be selling it for more than $250. Yeah. So, there's some calculus to be done where it's like, well, how much is this vulnerability worth in the wild? What's an insulting value?
Right.
How can we reward this person properly? And then you can get kind of cool with the results or the rewards, right? So Google pays out, their top reward is $31,337. So elite dollars, right? Nice. And that's pretty cool, you know? Yeah. So you could pay out, instead of paying out $200, do $256 or $1,024 or whatever. And then you could do things like issuing custom t-shirts. So not just like, don't send them the, my company t-shirt, send them super elite black hat, white hat hacker sort of t-shirts that you can only get if you submit through the bug bounty program. Yeah. Facebook does a thing where they pay out their bug bounty rewards in white hat hacker debit cards. So you get a debit card that's totally black and it just says white hat across the top. And it's loaded up with that amount of money. Right. That's pretty cool, and so people talk about it and stuff like that. You could issue challenge coins, all kinds of kind of cool stuff that you could do.
Okay. Excellent. So have you been to Source before?
No, this is my first time.
Okay. So all right, so you work for a company, and what made you guys want to sponsor Source this year?
Yeah, so it's a local conference. I always like to support local conferences. I think this one started in Boston, but our main engineering team is here in Seattle.
Right.
We actually have our headquarters is in Wilmington, Massachusetts, which is just outside of Boston. And so we actually knew Rob, the organizer of Source.
Okay.
And so when he came over, we started to talk, and mostly I submitted my talk, and when I heard about it, and then we started to talk some more, and he was like, "You want to sponsor?" And we said, "Yeah, that sounds great."
Oh, so it wasn't a pay-to-play thing. You actually
No.
responded to CFP and everything.
Yeah,
Okay.
yeah.
Okay.
I submitted my talk, got accepted, and then we started to talk about sponsoring.
Fantastic. Okay. So you looking forward to any of the other talks? I know other than yours, there's lightning talks coming up, which I've been asked to speak at. I don't know if that's going to be a thing or not, but is there anything else you're looking forward to for the rest of the day?
Yeah, I looked over the list. They all seem pretty good. I saw one this morning on UEFI stuff and one on some risk ranking. Overall, it's been a really good conference, and I've been happy to kind of sit in on some of the talks and hear about stuff. It seemed like a wide range of talks, from really technical talks to some pretty high-level businessy type talks. So yeah, it's been pretty interesting.
Yeah, I found it. It's definitely not a typical security conference. The food spread's way better than most cons that I've been to. But there's workshops on public speaking and how to be a better speaker. There was a threat modeling one with Robert Hurlbut. I just find it a different vibe at this conference, and so
yeah, for sure.
Yeah,
I mean, if you've been to HushCon or Recon or something like that, it's very focused on a specific topic of highly technical, challenging topics, and those are great. For security engineers and folks in the industry, that's where we get our our knowledge and kind of share and work with each other. But I do think that it's really important that other types of conferences exist, where it's like, I work for an organization that doesn't focus on security all the time, and I want to learn more about security.
Right.
So, we've joked about even rolling out like a NoobCon, right? So, just hey, you're new to the security industry, this is some things you need to know. I think it'd be really useful.
Yeah, we had the hardcore firmware stuff. I didn't get to see the Twitter intelligence ones. All these videos are going to be on their YouTube channel. But it just ran the whole gamut, which I was really nice. It was really nice to see. There wasn't a blue team or red team talk. There was some anybody talks that you could just show up and do. So it was very nice.
Sure.
So, Joe, if people wanted to discuss bug bounty items or your talk with you, is there a way they can get a hold of you online, on the Twitters?
I'm not on the Twitters. I have long dismissed all of my social media stuff, but I'm always happy for email. So joe@securityinnovation.com.
Okay, right on. Well, thank you, Joe, for coming on.
Thanks a lot.